Okay, let's continue to discuss another type of question, which is about the buoyancy. The buoyancy force is due to the pressure difference. The pressure at the top and at the bottom of an object has a depth difference, and therefore the pressure is going to be different. And since the force can be calculated by the pressure and the area, you multiply these two, then you can get the pressure force. Pressure different, and if the area is going to be the same, then the force is going to be different. The larger force is going to have a larger pressure, so more of the depth, more of the pressure. Therefore, the force at the bottom is going to be larger than the force at the top. Since the direction of the pressure force is always perpendicular and against to the object, so the bottom force going up, the up force going down, therefore you have a pressure force that go upwards, because bottom going up is larger than the top going down. Then talk about the buoyancy, you have to talk about the Archimedes principle. If you look at the slide right now, that we actually summarize what the possible situation that you could have. Doesn't matter which kind of a scenario, the Archimedes principle is always valid. And which means the buoyancy force is equal to the fluid density and multiply with the volume, which is the volume being displaced by the object, and multiply with the g, where the g is the 9.81. So that is our buoyancy force. Now be careful about the rho, the density that you use. This density has to be the fluid density. The volume is the volume that is submerged in the water. If it's partially submerged, that's not a total volume. You have to just use the volume that is under the water. Well, it could be some other kind of fluid. It doesn't have to be water, but it's something that's submerged in the fluid. So this one always works. Doesn't matter what kind of situation that you have. Then you look at several different situations that we listed here. Float and sink. These two are more like a static. This thing is just at there, and it's just stay there. The floating and sinking is like in motion. The floating is going upwards, the sinking is going downwards. When we ask you to draw the free body diagram, there's always two forces exist if you have an object in the fluid. These two forces is the weight and the buoyancy force. If you tie something, or you connect something, or you put something touch with the object, then you will have some other kind of force acting on the object. So over here, this picture that you're already familiar with, that we did one in the practice exam, we did one in the actual exam. One is for the same volume and the other one is for the same mass. And the scenario is going to be different. So let's think about this. Let's think about one other situation, and then how do you determine whether the buoyancy force is going to be larger or smaller than compared to each other, or could be the same. Let's look at the first situation, which you have the same mass. If they have the same mass, and it's kind of just tell you it's the same weight, because the weight is equal to mass times g. And if you look at the situation, what is the situation that your buoyancy force will be equal to the weight? Well, this is the situation that you have buoyancy force that is always going to be equal to the weight. when things is partially or fully submerged, the weight is going to be equal to the buoyancy force. So just based on, let me just write down this with like different rule. Let's say this is a 1 and 2. Okay, most of the time we're looking at whether they are, most of the time we look at a static situation. If there's a floating or sinking, then we can ask you to find the acceleration as well. So just think about 1 and 2. And think about they have the same mass or the same weight. And then you look at a situation like this. A and B and D both float. The only difference is partially or fully submerged. So A is partially submerged, D is fully submerged. But it doesn't matter which case that is. Their buoyancy force is going to be equal to their weight, which means their buoyancy force should be the same if they have the same mass. Then let's look at the situation of B and C. Well, the B is also float, but it's not like a fleeting float. It connects with a string. And that's why in the exam we wanted you to draw the free body diagram first, because if you draw the free body diagram, you will identify what are the forces acting on the object. So let's draw a free body diagram on that one. For the box B, you have a weight, you have buoyancy force, they're always going outwards. Now this force is going to be larger than the weight. Why? Because it connects with the string. So it connects with a string, meaning there's a string force going downwards. Will the string force equal to the weight? Well, not necessarily. It depends on the situation. But the sum of these two is going to be equal to your buoyancy force. Okay. Now what about situation of C? If you have a situation at C, it also have a buoyancy force. Will this buoyancy force equal to its weight? Well, you have a weight going down, but why would it sink? And you look at here, it sink was because its weight actually is greater than the buoyancy force, and that's why it will keep on sinking until it touches to the ground. When it touches to the ground, and you're going to have a normal force. And what is the direction of the normal force? Direction of the normal force is always against the object. So it's coming from the bottom of the tank and go up to against the block. So your normal force is going this direction. This is the normal force. It's more obvious if you write the force equation to find what is the net force acting on the object. And the net force is going to be 0 because we are looking at a situation that's going to be stationary. It just kept at the same situation there and is not moving. So we write the net force of the B, and this should be equal to 0. And if you make going up to be the positive, then you can write the F of B minus W minus T equal to 0. if you look at a situation of A, and that also going to be equal to 0, then what are the forces acting on the A? The A only have its weight. It also have a buoyancy force. Right. So this, let me just say, we use F of A to represent the buoyancy force of the block A. So this is the block A buoyancy force minus W, that will be equal to 0. Now I use W for all of them because they have the same mass, meaning their weight will be the same. What about block C? Well, your force going up is the buoyancy force. Again, I'm going to use the subscript to represent the block. M minus W. And what about M? Plus M. That is equal to 0. A is equal to D, so I don't need to write a D. And we just want to compare the three. You want to compare the buoyancy force, then you make the buoyancy force equal to something, so put everything on the right. So we can write this in terms of this way. Okay, now it's obvious that you can see which one is larger. They all carry with the weight of the object itself, but one is going to plus the T, and one is going to be subtract with M. So the B buoyancy force is larger than the A buoyancy force is larger than the C buoyancy force. And A is equal to D. So that's the case. They have the same mass. What about the volume? What happens if we have the same volume? Well, the volume is the things that will determine your buoyancy force based on the Archimedes principle, because if the volume displace the fluid the same, then their buoyancy force should be the same. And you look at the graph, the B and C and D, they all fully submerged. It just one has to be connected with a string, and the two are going to, either one is floating in the middle of the fluid or one is sink to the bottom. But because they displaced the same amount of the volume, so they have the same buoyancy force. So what we say is the B, C, and D have same half of B. Because they displace the same volume. Now what about the A? Well, A you displace less, so your buoyancy force will be smaller. So B, C, D are the same, and A is smaller. Okay, so I hope that you understand this. Now let me just give you one more situation. What happens if, let's say the D, we make it not in this way, but we make it in this way. So we have a ceiling, but we connect this one with a string. And the block D happen to be stand still at that position under the fluid. If that is the case, then how do you draw the free body diagram of that? Let's make another tank over here to just isolate that situation. So this is the water level. We have a sitting on the top. We connect the string to the block. Let me use block E so to distinguish the difference. If you look at the E, then let's look at the free body diagram. You have a weight going down. And if this is a situation, do you think the density of this object is higher or smaller than the fluid? It's going to be higher because it's actually sink. It's sinking. If you don't have a string, it's going to go down. And that's why the string over here is going to have some kind of string force. The string force going away from the object, so this is the direction away from the object, so let's make this one to be a tension force. And what else this object will have? This object also going to have a buoyancy force, and buoyancy force going upward. Okay, let's make this one F of E, but you know this is a buoyancy force. And now if you write this free body diagram, if you write the equation of the net force, then the net force is the sum of these two forces, the buoyancy force on the object E plus the tension force is equal to its weight. And therefore you can write the buoyancy force of the E is equal to W minus T. So that's how you find the buoyancy force. Now we can find the tension force. If they give you the volume, can you find out what's the buoyancy force of E? Well, F of E, based on the Archimedes principle, that will be rho of the fluid times the volume of the object, because the total volume displaces the fluid, times the G. So this will be the volume of E. Okay, let's look at the bottom two questions and see if you can apply those ideas with the equation of the motion, which is actually simply just look at the summation of the force and to see can you solve this problem. The first problem is looking at the block of C. So let's look at this question here. We look at the block C, and they give you this one here, which is a density. It also gives you the fluid density is this. And we want to find what is the normal force if the mass of the sea is this much. Okay. So block C. The block C, if you look at the free body diagram that we write the summation, the equation of motion, which is right here, the F of C, which is the buoyancy force of the sea, is equal to W minus M. Then let's look at each one of them. Let's look at the weight first. Now, it's toward to the end of the course, you should know what's the difference between the weight and the mass. The weight is equal to the mass times the G. The weight is the result of a mass attracted by the Earth and give you an acceleration of 9.81. So you have 3 kilograms times 9.81 meter per second square. That will give you the weight of the object, and that is going to be in terms of Newton. So that turns out to be 29.4 Newton. Our goal is to find the M, so let's look at what is the FC. FC is the buoyancy force of block C. So what is the buoyancy force equal to? And that's Archimedes' principle. The rho of the fluid times the volume of the object, because that total volume displaced the fluid, and multiply with the G, which is 9.81. Let's look at the fluid. It's given 1025. What about the volume of C? Well, it doesn't give you the volume of C. It gives you the density, it gives you the mass, but based on these two, we can find out what is the volume of the sea, because we know density is equal to the mass divided by the volume, or volume is equal to the mass divided by density. So this one is equal to the mass of C divided by the density of C, and which we know the mass is 3 kilograms. The density is 1500. Okay, so then you can find out what this is. The volume is 2 times 10 to the negative 3 meter cubed. So you put these things together, then you can find out what that is. So this will be 2 times 10 to the negative 3 times 9.81. Then you will get the result of this one here. It turns out to be 20.1 Newton. After we got these two, then you can use the equation to find the normal force, because we know the normal force is equal to your W minus your buoyancy force, and W is 29.4 and buoyancy force is 20.1. That gives you 9.3 Newton. Okay, the last one here that we're going to show you is what happened if we wanted to find out the block of B. Now here, this one should be the B. Okay, so if we look at the block of B, and it gives us the density of the block B is 800. The fluid still 1025, and we want to find the tension force. And we make the mass of that is also equal to 3 kilograms. So let's look at the block of B. Then you write down the force equation. The force of B is equal to the weight plus the tension. So we already find out what is the weight, right? So the weight is 29.4 Newton. What about the buoyancy force on B? Well, Archimedes' principle, fluid times volume of B times G. That's 1025. Then what about the volume of the B? Still, it doesn't give you, but you the same idea. You can use the mass of the B divided by the density of the B, which is equal to 3 kilogram divided by density, which is 800. And then you can find out what this one is going to be. So that will be 3.75 times 10 to the negative 3 meter cube. So we multiply this and multiply with 9.81. Then you got the buoyancy force in this case. And that turns out to be 37.7. And then you can use the equation to find out the tension force. Now we know F of B, 37.7 Newton, is equal to the weight, 29.4 Newton, plus the tension force. Therefore, your tension force is the difference of these two. And it turns out to be 8.3. Okay, so I hope that you understand from this explanation, fully understand how you can apply the Archimedes principle, and make sure that you understand the difference, that you have the same method, same volume is going to give you different results. I'll see you on the next question.